Hello friends, welcome to the next chapter of object-oriented programming. And in this chapter, we will cover what are constructors and destructors in C++, or you can say what are constructors and destructors in object-oriented programming. So let us share my screen with you and PPTs with you. So constructor, we will cover constructor and destructor in C++. Constructors. In the last lecture, we have covered that a class is a combination of data members and member functions. But sometimes we need to initialize the values of these data members, the variables, object variables, which we have defined in our class. We need to initialize the values of these data members at the creation of the objects of that particular class. So talking about what are the constructor functions in C++. These are treated as a special member function with exact same name as the class name. These are called special because constructor name is same as the name of the class you have defined. The constructor name is same as the class name. Reason compiler uses this character to differentiate constructors from the other member functions of the class. Constructor is also a member function, but it is special because the name of the class and the name of the constructor remain same, and it tells the compiler that this particular function is our constructor function, which is having same name as of the class name. Constructor must not declare a return type. Constructor cannot return anything, and it is required that it will not declare any return type, neither integer, character, float, or not even void can be declared as a return type of constructor. During practical, we will see if we write void before the name of the constructor function, then what type of error it will create. They can be defined inside or outside the class definition. Constructor can be defined inside the class as well as outside the class. These are automatically executed. A constructor function is automatically executed when we create our objects of the class. When we declare the object of the class, it is automatically executed by the compiler. It uses to construct, that means to initialize all the data members of the class. Constructor. Constructor means construction. It is doing the job of construction. Construction of the objects, data members of that particular class. So these are automatically invoked by the compiler. This is the syntax of the class constructor. First, the class name. Class name is defined as a class name here. And in the public section, a particular member, I am highlighting this member function. This member function is having the same name along with the parameter list. It may be, it is optional. It is having a list of parameter or it is not having a parameter list, depending on the type of the constructor, which we will cover further later. So this is the syntax of the constructor, which is showing how we can define a constructor. More we will see practically during our program execution. And types of constructor. First one is the default constructor. Suppose we have user have not declared any constructor function in the class. So what will happen? The compiler, when we execute that program, which is not having any constructor function inside the class, when we execute that program, then compiler will automatically create internally, or you can say implicitly. The compiler will implicitly create a constructor inside and execute and create the objects of that particular class, which is not having any constructor. A constructor with no arguments. In the definition is a default constructor. It is the type of constructor in C++ usually used to initialize data members with the real values. Coming to the next slide. Second one is parameterized constructor. The constructor which is having some parameters. While declaring the object of that particular class, we will send the parameter to the constructor, and based on the values of these parameters, the values of data members are initialized We will check it also during our practical example. So this syntax is showing on the slide, like class name, and in the public section, a constructor is defined with the same name as that of the class, along with some data type and variables. This one, I have highlighted this thing. So this is a parameterized constructor. And third one is a copy constructor. A copy constructor is a third type among various types of constructor in C++. This member function initialize an object using the another object of the same class. Means if we want to create the copy of a constructor into the another object, if we want to copy the values of an object into some other object, then we can create this copy constructor and we can call this copy constructor. It will exactly create a carbon copy of the calling constructor. And coming to the second function, which is called destructor. Like a constructor is doing the job of construction, the destructor function will do the job of destruction. That means destroy the constructor objects. It will destroy the objects created by the constructor function. It is very, very important function. It is also a special member function because destructor is also having the same name as that of our class name. So destructor is an instance member function which is invoked automatically whenever an object is going to the destroyed or it is going out of the scope. Meaning a destructor is that last function that is going to be called before an object is destroyed. It will be executed at the end of the program. Destructor is also a special member function like constructor. Destructor destroys the class objects created by the constructor. Destructor also has the same name as their class name preceded by a tilde symbol. It is to differentiate it with the constructor function. Compiler will check if there is a tilde sign. If there is a tilde sign before the function which is having same name, then it is treated as a destructor. And if it is not having a tilde sign, then it is treated as a constructor function. It is not possible to define more than one destructor in a class. So there is only a single destructor which is defined inside a class. So friends, let us move to the practical part of the constructor and destructor chapter. We will use the same Dev C++ compiler to check our execution of constructor and destructor program. So I will delete all these lines from the program so that we can start it from the very beginning. So let us see. I have already declared these two header files, include iostream and the namespace std. The already predefined functions we are going to use in our program. So let us declare a class. I am declaring a class here with the name num. Num is the name of my class. Now I am declaring my data members. I have declared two data members of integer type, that is simple integer x and integer y. I am writing here comment that these are my data members. And I am not declaring any access specifier here. That means by default, this integer x and integer y are under the private section of the class. And the name of the class is num. Fine. Now I am declaring my public section and I will declare my constructor here now. The name of my class is num. So I will declare a member function with the name num. And I have created a constructor. This is my constructor function. I will write some comment here so that it can be identified. Constructor member function. So this is my constructor member function. If I leave it empty, if I leave this constructor empty, the body of the constructor is empty. If I do not write any statement here in the constructor, then it will be treated as a default constructor. It will be treated as a default constructor, but we do not need to create a default constructor, as it is by default automatically created by the compiler implicitly. But if you want to initialize some value for the data members, like suppose my data members are having X, I initialize this data member with the value 0, and data member Y, I initialize with the value 2. Okay. So this is my first constructor function. This is my known. Now this default constructor is called, because as it is initializing the value, this is called parameterized. Non-parameterized. This is my non-parameterized constructor member function. This is my non-parameterized constructor member function, because it is not having any parameter inside the definition of the num function. So now I write a function to display my output. Let's the name of the function is display, and I simply write a output statement here to check the values of my data members. Fine. Simply display the values, the value of X and value of Y. So this is my output function. So this is my complete class. I'm not making it so lengthy so that we can easily understand it. So simply I will revise this class once. My class name is num. Then I declared two data members X and Y here. Then I declared a constructor function. It is having the same name as of my class name. And then an output function display, which is displaying the values of my data member X and Y. So here I am terminating my class and I am creating my main program. Int main, as you already aware, with the definition of the main, so simply I will return 0. This is the basic structure of my main function. And now what I will do, I will create a object of my class. Let's say num n1. N1 is the object of my class. So I'm writing a comment here also, declare objects of the class, declare object of the class. And now I'm calling my, as we know that when we declare the object of a class, the constructor function is automatically executed by the compiler. We need not to explicitly call the constructor function, because it is already defined in the concept that the constructor function will automatically execute it whenever we create the object of that class. So now, when this statement will be executed, num n1, I have highlighted this statement, num n1. So my compiler will execute this constructor function for my object n1 and will initialize the value of X to 0 and Y to 2. So we can check this with the simply n1 dot object dot member function name, object dot the name of my function is display. Very simple. The name of my function is display. So let us check what will be the output of my program. Simply first compile it when there is no error and warning in the program, and then we can execute it. So we can see that in the output, we can see that in this statement, value of X and Y is initialized to 0, 2. The value of X is 0 and value of Y is 2. So it is clearly showing that the constructor function is, we have not, we can check in the definition of in our program that we have not explicitly called this constructor function. We have only declared the object n1. And then call the output function display, member function display, that is displaying the value of my data members X and Y. So in the output, when we check this, So it is already defined, initialized the values of data members X and Y, 0 and sorry, 0 and 2. So here, this is our one constructor default, or in this case, you can say it is a non-parameterized constructor. So we can have, friends, we can have more than one constructor in the same class. So now I am going to declare one more constructor in the same class. After this first constructor function, I am declaring my second constructor function here. Immediately after the first constructor, I am declaring it here. And this time I am taking two parameterized. I am making it a parameterized constructor. Before its definition, I will write here in the comment that this is this is my this is a parameterized constructor function. This is a parameterized constructor function, but we have not defined any constructor till now. So now we are defining, we are declaring parameterized int A and int B. These are my two parameters of integer type. Because my data members are of integer type, I can initialize the data members with the integer values only. So I have declared integer A and integer B. Now inside this constructor function, I will initialize my X with the value of A. I will initialize the value of Y with the value of variable B. So now this my parameterized constructor is completed. But when we check our main program, we can see that we are having only one object in the N1 in our main program, and it is a non-parameterized. So how we can declare our parameterized object? I am declaring N2 and sending two parameters to N2. Like in this case, I am sending 5, 6. So here, whenever this statement is executed, creation of objects, whenever this statement is executed, compiler see that N1 object is not having any parameter. So in that case, it will execute this non-parameterized constructor in case of N1. In case of N1, it will execute this non-parameterized constructor, but in case of N2, N2 is having two parameters with it, 5 and 6, two values with it that are of integer type. So compiler will match second constructor function, num integer A and integer B. It is having two parameters. So in case of N2, it will execute the second parameterized constructor. So we will call the second display function for the second object, our display function for the second object. So let us see, we can write a output statement before this to just identify in our output. Cout, I am writing cout values of non-parameterized object because it is initialized by the N1 is initialized by the non-parameterized constructor, and in the second case, values of a parameterized a parameterized object, you can say here, and I can also write object here. So now let us check this. I'll check the output of this program. First compile it. It will show if there is any error. No, there is no error. So let us now run it. So when we run it, we can see that the value of the non-parameterized constructor, value of X and Y is 0, 2, 0, 2. It's the case of object N1, which is a non-parameterized constructor, and we do not pass any value to the object N1, and the compiler execute a non-parameterized constructor in this case, or you can say the default constructor, and the value of a parameterized object, value of x and y are 5 and 6. So here the value of x and y is 5 and 6, which is case of our second object N2. In the same way, we can create one more object here. N3, it is having parameters, suppose 7 and 7, and again N3 dot display. So now N3, for object N1, the values will be by default 0 and 1. And for object N2, the values of we are passing 5 and 6. And for object N3, we are passing values 7 and 7. So let us check our output. Now it is showing. You can see that the values of the parameterized value of parameterized constructor is 5 and 6 and 0 and 2. I think we have not called display function for N3 object, N3 dot display. We have called it, but we didn't get the output. N3 dot display, N3 7 comma 7. The program is, let us execute it one more time. I think some error can be there. 5 and 6. Value of x and y are 5, 6. Value of x and y is 0, 2. It is giving only output for N1 and for object N2. There may be some problem inside the program, I think. N3, 7, 7, and 2. Let us now check it this way. If I am commenting this N2 object line, check this with this method. 5, 6 value of a parameterized constructor xy 5, 6. What is the problem? Why it is taking the same values for 5 and 6 display? I'm calling the function display. There might be some problem. Let me check it. And 2 dot display and 3 dot display. I think there is everything correct in the program. Then why it is not giving the value of N3 object? N1, N2, N3, N3 dot display. Let us compile it. There is no error, and then run it. Yes, now it is giving. I think earlier we have not compiled the program after declaring the object N3, but now we are getting all the 3 objects N1. So value of my N1 object is here. N1 object is calling the default constructor, non-parameterized constructor. So this is the value of x and y 0, 2. And the value of my N1 object is here. This is x and y is 5, 6. For N2 object, we have passed 5 and 6 values to the parameter of the parameterized constructor. And this is the third N3 object. We have passed values 7 and 7 as the argument of the parameterized constructor. So now this is clear that we can, this program is giving example of a parameterized as well as non-parameterized constructor. So we can create our third type of constructor, that is copy constructor in the same program. Let us try that also. So I think up to till you have cleared that what is the concept of parameterized, non-parameterized, and default constructor. So let us now declare our third type of constructor, that is our int %a and int %b. This is the definition of my copy constructor. I will write the comment here. This is copy constructor. This is my copy constructor. Oh, I need not to declare two variables here. I will declare only, it will accept a type of object here, because we are going to copy one object into the values of object into the another object. So I will pass a num object here only, num ampersand. Suppose T. T is the name of my temporary object. I am declaring a temporary object here that will accept the value of the other object and copy that. So my X assign T dot X and Y assign T dot Y. So I am copying this temporary object. I am copying the values of X and Y values, data member values of this temporary object into my current object X and Y. So let us declare the object for this particular constructor. We can declare the object in the same line again. So I am passing, this time I am passing N4 and I am passing N2 object as a parameter. I am passing N2 object as a parameter here. So now now the N2 object will be passed to, whenever this statement is executed, this N2, N4, while creating the object N4, this N2 object will be passed as a parameter to this my copy constructor. The compiler will check. If an object is coming as an argument, it will definitely execute this function only, this member function only. It will execute this constructor function only. So now N4 dot display. N4 dot display. So before that, I am again writing a output statement here. This is value of my copy object. This is value of my copy object. Let us compile this function. Compile it first, but it is giving okay. We have missed one semicolon here. So then again compile it. It is not having any error. So now let us check in the output. Now again, you can see that at the end statement, at the end of the output, this is the value of copy object. The value of X and Y is 5 and 6. And these values of the object are equal to object N2. Here, this is equal to object N2. Okay. So we can see that the N2 object is exactly copied into N4 object. And this is the job of our copy constructor. We can make it more understandable by writing that values of rather writing the known parameter as value of N1 object here, N1 object, value of this is parameterized. We are having two parameterized N2 and N3 object, values of N3, N2 and N3 object. And here I can write the value of copy object. Copy means N4 copy object. So again, we can check the output. Again, compile it and again run it. So we can see now it is clear in the output that value of N1 object XY is 2, 0, 2. And value of N2 and N3 object, that is parameterized value, is 5 and 6. And value is 7 and 7. For N2 it is 5 and 6. For N3 it is 7 and 7. And as we have called the copy constructor for N4 object, N4 is copy of N2. It is also having same values 5 and 6. So friends, this is clear from the program that in the same program, first, I am summarizing the program here. First, we have created a class with the name num, which is having two data members X and Y that are of integer type. Then in my public section, I have created a known parameterized constructor, known parameterized default constructor, and it is initializing the values of X to 0 and Y to 1. Again, my second parameterized constructor, and then third my copy constructor. And then one more member function to display the output of the data members. And in the main program, I have created various type of objects. here N1, which is calling the non-parameterized or default constructor, N2, which is calling the parameterized constructor with the initial value of 5 and 6, N3, which is calling the default parameterized constructor with the values 7 and 7, and N4, which is calling the copy constructor. And we are sending N2 object here as a parameter. And we have already checked in our output that our program is working perfectly and giving correct output. So this is the concept of constructor and destructor. Sorry, we have not declared constructor. Sorry. We have not declared constructor in our program. So let us declare before closing the lecture. We will declare one destructor function also here. And there is nothing to write inside the body of the destructor, but it is till now it is not a destructor. It is a constructor. We will make it destructor by writing this tilde sign. We can make it by writing a tilde sign. Okay, destructor will be, I think, initialized before the member function. We will define it here after the constructor. I am having a and now this is my destructor function. Let us compile it. There is no error, and then let us execute it. So my programming is running perfectly, but I didn't get key when my destructor is called or when it or not called. We are not having any idea. So to check whether our destructor function is executed or not, I will simply write a statement here. Destructor executed. Okay, now let us again compile it. And then, sorry, I have not put semicolon here. Again, compile the program. There is no error, then run the program. So in the output, we have seen that destructor executed, but the output statement contains that this statement is 1, 2, 3, and 4 times. The destructor is executed 1, 2, and 3 times. Sorry, 4 times. It is executed 4 times. First time it is executed first time here, then again executed second time here, then again executed third time here, and again executed 4 time here. And the reason behind this is that we have declared 4 objects of our class, and to free the memory from all the objects, destructor will be executed depending on the number of objects we have declared for that particular class. So for first time it is executed for object N1, secondly it is executed for object N2, N3, and N4. If we have more objects, it will be executed. But now we are ensured that because our output statement is printing in the output. See out destructor executed. It is printed in the out as a output. So we are sure that our destructor function is executed and all the memory allocated to the objects by the constructors, different constructors, is free from, or you can say deallocated from the objects when the execution exit from the program. So friend, this is the concept of constructor and destructor. I hope you get an idea how the constructors, we can say that how the multiple constructors, you can also say that this is constructor overloading in a single program. This is also known as, you can say it as also a function overloading, because we are having the same name member function multiple times. Here we are having it 3 times. So it is constructor overloading, or you can say it is function overloading. I will write a comment here. Program that uses constructor, overloaded constructor. Program that uses overloaded constructors. So I hope friends you have gotten very good idea of the constructor, destructor, and how these are implemented in our C++ program. So thank you very much for this video, watching this video, and we will meet in the next lecture of the C++ programming. Thank you very much, friends.